Hello everybody, my name is Elton Troy and welcome to Lab Report 1 on charged tapes for Physics 2212. Here's the table of contents. We have the introduction, the computational model, the results/observation, the discussion, and conclusion. Here for the introduction, the goal/purpose is to determine how much excess charge is on one piece of charge clear tape and to create a simulation to model the charge on the tapes. The assumptions are to ignore air resistance on the moving object, to treat the tape as point charge, and that each U tape made has the same amount of charge and is evenly distributed. Some errors that may occur are some inaccuracies when measuring the distance between the tapes. And the concept/fundamental principles, we have the conservation of charge, Coulomb's law, electric force, electric field, and superposition principle. The preview of the lab results is that with a 0.16 meter tape at 0.05 meters, it has a charge. It reacts at 0.05 meters, and it has the excess charge of 2.1 e to the negative 8 coulombs, in which the top tape was positively charged. The method is that we place a piece of tape on the table, then another piece of tape on top of that tape, and then once we take those two pieces of tape off, we then separate them, in which they are charged. We then place the blue tape on the bottom or top, and then find the distance between them in which the red tape finally reacts. In this case, for our experiment, we have the blue tape here on the very top. Note the charges are opposite. The computational model is that the length of our piece of tape was 0.16. The mass of it was 1.6 e to the negative 4 grams. The distance between them in which they finally reacted was 0.05 meters, and at equilibrium, in which the gravitational force and electric force at equilibrium, the magnitude was 1.5 e to the negative 3 newtons. The codes translated from the equations. In order to find the charge, we set the electric force equal to the force of gravity. Sorry for this. This is not supposed. The force of gravity is equal to mass times gravity, and when we set these equal to each other, we have k q1 q2 over r squared is equal to mg. Note that r represents the magnitude. Here we have r magnitude equal to square root of x squared plus y squared plus z squared. And note that q1 and q2 are the same, so we just leave it as q squared. And we set this here to q is equal to square root of fg times the magnitude, which is r squared, divided by k. Here we have our codes. This at the bottom here represents the calculation for excess charge. And here we have the factors that help calculate this. We have the magnitude, r hat. Here we have UFPES, which represents k value. We have gravity, the scale factor, mass, and distance. Here we have the visualizations for the model. We have the arrows representing the electric force and gravitational force. And here we have the arrow that represents our electric field. These are the calculations right here that help it. The results/observations, we have excess charge Q, which is equal to 2.1 e to the negative 8 coulombs. Here at the bottom tape, we have the electric force with an orange arrow, the force of gravity in the white arrow, which are at equilibrium. Here with the green arrow, which is pointing towards the top tape right here, blue ball right here. This is going forward, same direction as the electric force. Here, when calculated, the excess charge is 2.1 e to the negative 8, and here we have the rest of the vector components of the electric field, the electric force vector, gravitational force, in which the net force is 0. Discussion. What if the electron had a positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? The directions of the electric forces remain the same as they are oppositely charged, and then nothing changes really. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? In this case, the tapes are charged by static electricity. Touching them allows charges to move to or from your hands. This makes measuring inaccurate as your hands become the conductor, and there will be less charge on the tapes. Conclusion: the computational model was accurate, and that treating the long tape as the point charge led to a somewhat accurate measurement. Furthermore, with tape being 0.16 meters long and between the distance in which the tapes are affected, which is at 0.05 meters. The bottom tape was affected, in which the excess charge was 2.1 e to the negative 8 coulombs. That is the end, and thank you for watching.